Good morning, ladies and gentlemen. Welcome back. It's Mr. Chen for MCR3U, Functions 11. And today's lesson is an introduction to our sequence and series binomial theorem lesson unit. I apologize, it's been a while since I probably posted a video. As always, feel free to pause the video. Please make sure you refer to your textbook and your notes and the handout. And of course, the CEMC courseware that has been linked in the Google Classroom is there for you. So hopefully you got a chance to look at the three lessons 1, 2, and 3. And lesson 1 is actually pretty basic. I don't think I really have to go through all this material for some of you. In fact, the very first lesson is the introduction, just to make sure you're looking at patterns. But there's some terminology that we have to get across. So as I just scroll through this really quickly, you don't have to do all the questions, but if you need some more support, feel free to do some of the questions. And so what you're really supposed to be doing out of this is trying to figure out some kind of patterning and getting used to our notation. And really quickly, sorry, I had a little tech issue. Really quickly, you're just trying to find out what you should be getting for this. So a lot of you already know the pattern for this. Find the 10th term in the sequence. Clearly, there seems to be some kind of pattern here that's going up by +5 for question 1b, +5. Right, so a lot of you actually can generate a pattern, but what we're trying to show you is that the notation we have for the general term is this t subscript n. Some textbooks also use this notation, a subscript n. Now the n stands for its position in a sequence. And again, really quickly, a sequence is just a list of numbers that are actually placed separated by commas, and there is usually a pattern. So it's actually easier just to kind of do a question here with question number 3. And this just determine the first 3 terms of each sequence. And so really what you're doing is just practicing using the formula. And let's just do question 3e. So basically, the first 3 terms are going to be when the position is n equals 1, n equals 2, and n equals 3. So really, really easy. So this just becomes some algebraic notation. For the first term, using this rule, and again, you're not memorizing these rules for question 3. You're just plugging into the equation. So the equation for the general term is n squared minus 1. And so I think a lot of you understand we're going to do 1 squared minus 1. And 1 squared, of course, is 0. 1 minus 1, which is 0. So the first term of this sequence is going to be 0. And we keep on going. The second term, notice what I'm doing, t subscript 2. We're going to now change the 1 to a 2, and we're going to square it, because that's what the rule says, minus 1. 2 squared, of course, is 4. 4 minus 1 is 3. And finally, for the third term, we're going to square that, minus 1. 3 squared is 9. 9 minus 1 is 8. So if you were to look at that sequence, what would it be? The first term was 0. The second term would be 3. And the third term would be 8. So this is the kind of generalization that we're looking at. So for question 3, I do recommend you try to practice going through it. And hopefully you're going to notice something. I actually find this lesson, this unit, kind of confusing, at the same time pretty formulaic, because there's some equations here, and I'm actually just not really good at the patterning portion. So as always, feel free to refer to your notes, and it might support you that way. Again, question 7 is really good to look at. You don't have to do all these questions, but a lot of you are noticing some kind of neat patterns of the graphs here, questions 7, D, E, and F, respectively. Question 8, of course, is a good patterning question here that you might want to try. And don't feel bad if you actually look at the answers, right? So question 9 looks at some really neat repetitions. Right, so the answer is actually there. So I'm actually going to skip lesson 1, even though all I really did is talk about general term and AN. We'll come back to this actually sequences in general terms because some of you, again, realize you could pattern this out. Again, I'm going back to question 1E, and I know this lesson right now is a little disjointed. So some of you are actually figuring out that this pattern is going up by 2. Oh, it seems to be multiplying by 2. Right? So the next one's going to be, what is that? 16, 32, 64. You keep on going. 128, 256, 1, 2, 3, 4, 5, 6, 7, 8, 512. 3, I can't count. Second, third, fourth, fifth, 6, 7, 8, 9, and 1024. So that's the 10th term. So some of you actually know how to generate that, but there must be obviously a faster way. So that's why I'm just trying to show it. So this, notice this seems to be showing a pattern or a rule that it's going to be multiplied by 2. So when we get to the second lesson, again, there's some general questions here, but basically the lesson 2 talks about this thing called an arithmetic sequence. That's how you pronounce it, arithmetic. I know it looks like arithmetic, but it's pronounced arithmetic. And basically, you're learning actually 2 equations. The first equation is its definition. If the sequence has what's called a common difference, and the letter D is for common difference, and a lot of you actually notice that some of them were showing a pattern where you take the second term and subtract it by the previous term. If the second term by the previous term is constant, and a lot of you actually know this also as what's called a first difference, then this pattern is probably a linear pattern. And that's actually what an arithmetic sequence is. So a common difference actually shows that portion. Now, I wish we had more time to talk about the proof, and the proof is actually written here, but a lot of students don't realize it because when you look at that continuous repetition of that addition, +1, +2, +3D, etc., that common difference, it's actually easier to learn it by its formula. And so just to write it above here, the arithmetic equation is the first term, that's what A stands for, plus n minus 1 times its common difference, where A, of course, it stands for the first term. You could have also written the first term as T1, right? And that's why you see this particular pattern here. Now, question 2 is actually a practical use, and it actually looks at our financial math, which we may or may not get to. But I just wanted to actually get to a real question here. So let's take a look at question 6, found on the page 2 of the package. Consider the arithmetic sequence 0, 4, 8, and it goes all the way to 44. So notice we don't know what term that is, and although a lot of you could say, Mr. Chen, we could pattern this out. Why don't we, like we did in that question lesson 1? Why don't we just do this? Well, with this question, we want you to kind of work with the formulas. So the way that most students would do is, first of all, the first term is 0. And just to make sure it is a linear pattern, arithmetic sequence, some of you are actually noticing what I'm doing down below. You don't have to do this. But basically, I'm trying to confirm that the difference between the first term and the second term, like 4 minus 0, it's +4. 8 minus 4, that's +4. And I'm trying to reinforce this rule of D is equal to Tn minus Tn minus 1. So the common difference is +4. And I'm going to be specific here because some students get confused with their signs. And honestly, it doesn't really matter. But just like I was trying to teach you, or maybe your teacher in grade 9 taught you, the first difference, it's always the second minus the first. With slope, it doesn't matter which is the first term or second term. But in this context, it does matter. So all we're trying to do is find the 8th term. So we're using that formula. A plus n minus 1 times d. So the 8th term is 0, that's the first term, plus 8 minus 1, which is really 7, times by 4. And that is the 8th term, 28. Now notice the second question, which term is 44? And again, some students would say, why don't we just pad it out? The common difference is 4, so we can keep on adding 4 and then figure out what 44 would be. However, again, what we're trying to do is actually figure out what the position, or really find n. That's what this question is asking you. So what could we do? 44 is equal to the first term. We know it's 0, plus we don't know what the n is, but we can put n minus 1. And then d is plus 4. Doing some algebra, 44 is equal to, well, 0 is nothing, so we don't have to worry about that. Using distributive property, 4 times n is 4n minus 4. Add 4 to both sides, which is 48 equals 4n. And then n equals to 12. Therefore, the 12th term is 44. Could you also check? Absolutely. So what we're trying to get you across is to figure out an arithmetic sequence. And like question 9 is a really good one to do. I'm going to let you figure that on your own. Question 8, we'll do that right now though. Let me just erase this up, even though it's circled. I don't want to confuse our viewers. Let's try question 8 first. So the 18th term of an arithmetic sequence is 54. So we know the 18th term is 54. And the 24th term is 36. Find the arithmetic sequence. Now there's some of you that actually can do this very intuitively, and that is amazing. That's why some of you actually are very fast or really good at patterns. I am unfortunately not really good at that. I am unfortunately, because I'm old, I like the equations that we have. But that's what we're trying to show you, some kind of algebraic proof to prove that we actually know what's going on. Because again, some of you know from the 24th term and the 18th term, you can find the average between the two and do something neat with that, which is really amazing. Don't get me wrong. However, what we're trying to do is 54 is equal to the first term, which we don't know, n minus 1, well, we know it's the 18th term, so 18 minus 1 is 17, but we don't know the common difference. So some are already saying, well, I don't know how to solve this, but some of you are slowly going to figure out what we're doing. The 24th term is 36. The first term is a. N minus 1, or 24 minus 1 is 23d. And so some of you are already noticing I'm actually numbering 1 and 2. And what are we going to do? We can actually use something that we were taught in grade 10, or some of you might have learned in grade 9, is elimination, right? Let's eliminate a by subtracting these two equations. And I need my calculator. Because I'm tired. 54 minus 36, that's 18. A minus a is 0. 17 minus 23, negative 6d. D is equal to negative 3. And that kind of makes sense. The 18th term was 54, and then the future in the list was 20. The 24th term was 36. It seems to be declining. So find the arithmetic sequence. We now want to know what's the first term. Well, it's really easy. Sub in d is equal to negative 3 into the first equation. So 54 is equal to a plus 17 times negative 3, because that's the common difference. Negative 3 times 17. First term is 105. So the first term is 105, the second term is 102, and it keeps on going. Now, what we didn't talk about is what's the general term, and so let's just do that in red. So for this question number 8, I know I've not finished, let's just move it down here. To find the general term, we know the first term is 105, and we know the common difference is negative 3. So the general term would be 105 plus n minus 1 times negative 3. Now notice what I did. I just plugged it into the equation. My neighbors seem to be cutting something. I'll just close my door. And so what we have to do is maybe write a general term. Now, what we're going to do is use some distributive property. So negative 3n plus 3. And then what we get is negative 3n plus 108. So this would be classified as the general term. Now, some of you also are kind of noticed something that I said linear way back at the beginning. So some of you are actually kind of seeing this also as some kind of equation of a line. So some of you already know that some of these questions can be solved by using some simple things. So that's lesson 2. Arithmetic basically in a nutshell. And let's just summarize it down here. Or let's go back to the beginning page. Let's just erase this. So I'll highlight it again. This is the, oops. You can't undo that. Let's try that again. So this is the equation. Tn is equal to a plus n minus 1 times d. And the common difference is the difference between the second minus the first, or the previous term. Let's get to lesson 3. Really straightforward. Again, some patterning here. You can hopefully notice that there's not going up a linear pattern or by a common difference. You can actually kind of check this. If you try the common difference between that, 11 minus 5, that's 6. And then 23 minus 11, it's 12. So this is clearly non-linear. So not arithmetic. So that's what you're supposed to discover with question 1 and describe the pattern in words. But today's lesson is obviously looking at geometric sequences. And again, you're obviously noticing something that's going to be multiplied. And so again, some of you are already noticing, hey, wait a second, this lesson 3 has our previous unit on exponential growth and decay. So you can skip page 2 if you want, question 3. And again, the questions here, 4, 5, and 6, they all seem related, right? And that's why a geometric sequence, again, is a sequence is basically a list that's separated by commas. And it seems to have this R value, right? What's an R value? Well, the R value stands for the common ratio. So don't get confused with the common difference. Common difference, you're subtracting the second minus the previous term. Common ratio is the division of the second divided by the previous term. And the formula that we have to look at is Tn is equal to the first term times the common ratio to the n minus 1. So let's just jump to one of the questions here. Let's try question 8. 139 dot 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 2187 is a geometric sequence. Which term is shown by 2187? And again, some of you say, well, can't we just count this out? T1 is 1, T2 is 3, T3 is 9. But a lot of you notice the common ratio is positive 3. So the first term, A is the first term, so that's 1. Common ratio is plus 3. How are we going to solve this? Well, Tn is equal to A r to the n minus 1. But we do know that the last term of this sequence is 2187. First term is 1. Common ratio is positive 3. We'll just put 3 to the n minus 1. So some of you are already realizing that the geometric sequence is probably some kind of exponential pattern. So there's a couple things you can do here. You can do some logarithms. And just to show you, some of you actually are aware that 3 to the 7 is 2187, and that is equal to 1 times 1. 1 times 3 is not really supposed to do that order, but anything multiplied by 1 is itself. So we can write 3 to the n minus 1. And since that is why we had to teach you that exponential equations, if the bases are the same, we can equate their exponents. And notice that n has to be a natural number, a whole number, right? So all of these questions here are pretty good. The only one I think I'm going to try to do with you is let's just try question. Let's just try question. I don't know. These are all good that you could probably do on your own. Fine. Let's just try question D. 9D. So we know the first term is 1, and we know 1. This is the first term, so we know this is second term, third term, fourth term, and the fifth term. So we know the fifth term is 1/16. So again, some of you are actually really good at patterning, but I think what we want to try to do is that's the fifth term, which is equal to 1/16, which is equal to the first term, which is 1, times r to the n minus 1, which is 4. So we have to equate them, right? So what could that possibly be? What could be that common ratio? Well, there's so many ways of actually doing this question. 16 to the negative 1, which equals r to the 4. And then we want to get the same bases. And I think we can do 4 squared to the negative 1, which equals r to the 4. And some of you are knowing what I'm trying to do. And maybe I screwed up. I'm tired. Oh, 2 to the 2. I'm sorry, ladies and gentlemen, my brain got stupid for a second. We're solving for r. And so we just wanted to do the fourth root. So that was silly of me. So the fourth root, when you do that, to the right-hand side, we have to do the left-hand side. So when you do the fourth root of 1/16, we'll solve for r. R will be equal to 1/2. So that's my fault. I'm sorry. So the pattern is, and feel free to generate it, because half divided by 1 is a half, and then we're going to get a quarter, and then an eighth, and then a 16th. So it's being multiplied by that half. I apologize for that little delay. So I think you should be able to finish this out. Try to do question 11. Some of the harder ones, if you feel that you can't solve them, don't worry about looking at the back of the package. This last unit on sequences and series, we're just trying to get used to the formatting of the equations. And as always, for this particular lesson, all we're trying to confirm for geometric sequences, which are exponential, that's the equation. And r is equal to Tn over Tn minus 1. So this is for geometric or exponential pattern. And as the previous lesson, lesson 2, for arithmetic, the equation is Tn is equal to a plus n minus 1 times d, where d is Tn minus 1. And again, this Tn minus 1, just to help everyone out, this really means the previous term. I hope this has been helpful. As always, I apologize for that little slip up there. My brain just got kind of tired. This is like my third time recording this. I've been having some tech issues, but hopefully this has been something that you can figure out. And then, as always, fire off an email if you need some help. Thanks for watching. Take care. Have a nice day.